From now on, the course will start getting more interesting because we will start creating nice visual effects using shader graph. And in this video, I'll show you how to create a nice fireball projectile. So let's create new Unity 2D URP project. Let's name it 2D fire projectile shader. And by the way, I'm using Unity 2021.3.7, so make sure you're using that to avoid any differences between Unity versions. So while the project is loading, let's discuss what we need to create this shader graph. First of all, we need a flame texture, which will be creating that in Adobe Photoshop. Then we need to scroll that texture over time to simulate the flames. After that, we need to create colorizing nodes that control the color of the flames. We will be needing two colors. The first one, the beginning of the fire or the flame, and the second one when the flames start to fade out. And thirdly, to make this looks interesting, we will be in need for something like a dissolve. So we will create a random noise that dissolves the flames as they go to the left or to the right of the screen. And as a final additional step, we can create a mask that fades the edges of the flames nicely. So as we planned, let's start by creating the flames texture inside Adobe Photoshop. Let's create a new Photoshop file and set the width and the height to 512. Create, and then use the bucket tool to color the background with black. To create the flames, we will simply use a rectangle, a white one. Then, after rasterizing it, we will use the smudge tool to create the flames. So select the rectangle, draw any rectangle. What is most important for our flames is to keep the right side similar to the left side. What I mean, we want to create a seamless texture, which means that we can scrolling it endlessly without showing or feeling that it's interrupted. So after we draw the rectangle, we simply right click and rasterize it to be able to smudge it. Then select the smudge tool, change the size of the brush as you wish, either by using the brackets or from the top left properties of the brush. Then start smudging the rectangle to create the flames of our fire texture. So keep doing this. Few smudges top right, few smudges bottom left, and be careful and make sure to keep the right edge and the left edge of the flames exactly the same. So try not to play or smudge the right and left edges. So just keep smudging and creating the edges of the flames. Make sure to smudge all places of the rectangle to remove the sharpness and only get smooth flames with some fade outs. So after creating those smudges, we also can add some more details by using the eraser tool to erase some parts and show that the fire dissolving while it's moving. So select the eraser, draw some lines inside the flame, then use the smudge tool again to blend them nicely with the flame. And once you are happy with your flame texture, just export it as a PNG, then import it to Unity, and now we can start scrolling it. To create a new shader graph, right-click anywhere in the project, create shader graph URP sprite unlit shader. And again, unlit shader means it will not be affected with the lights in the scene. Let's name it flames or fire projectile shader. Maximize the shader window to have freedom and get more comfortable while working. Then, as we agreed, the first node to create for any 2D shader, we start by sample texture 2D to render the base texture of our sprite. So create sample texture 2D node, then create a property. It should be texture 2D, and let's name it flames texture. Then link the sample texture 2D to the base color to render the colors of the sprite, and link then the alpha to alpha on the master node to have a sprite with some transparency. Now we can import the flames texture that we created in Photoshop to Unity and apply that as the flame texture so we can start seeing it visually inside shader graph and see how each node can affect that texture. So we want to scroll the flames texture on the horizontal axis, on the x-axis. To do so, we will be using the tiling and offset node. The tiling and offset nodes allows you to offset the texture on the x or y axis, also to tile it on those two both axes. But as you can see, if I start to move the texture on the x axis manually, it's not looping, it's not repeating. And that's because the properties of the texture has not set to loop. As you can see in the wrap mode here, it's set to clamp. We can change that to repeat, so it starts looping when we reach the end of the texture. And as I told you in Photoshop, to keep the right and the left edges the same, so this can scroll seamlessly. As you can see now, if I change the x-axis manually, it starts looping endlessly. So let's do the looping automatically using the time. To do that, simply add a time node. Then to control the speed, we can create a property, a float, to control the speed. So create a new float and name it flames scroll speed. Then use a multiply node to multiply the speed with the time. So we can have control of the scrolling speed. So create a multiply node, link both the time and flames scrolling speed property together. Then if we link that to the offset, we will see that the flames start scrolling to the bottom right, which is something we didn't want. We want it only to scroll on the x-axis. To do so, we can add a vector 2 node, then link the results of the multiply only to the x-axis while keeping the y 0, so we scroll only horizontally. Then link the results of the vector 2 to the offset. And now we can see the flames scrolling correctly, and we can change the speed of the scrolling and the direction using the flames scroll speed parameter that we created. Let's see that in the scene by saving this shader graph and going back. there is nothing to apply this flames shader graph to it in the scene. So to render the flames, we will be using the line renderer. So right click in the hierarchy, click effect, then line. You can control the line length by expanding the points positions. So expand the positions and you will see there are 2 points. Go to the second point and set the X to Y. With that, we will have a line with a length of 1 unit. Additionally, you can control the height or the width of the line using this width graph. And finally, in the materials section, you can see the sprightly default, but we need to create a new material to hold our shader, then apply that to our line renderer. So right click, create material, and let's name it flames material. Then drag the shader graph to our new material. Then assign that material to our line renderer. So now we can see the flames scrolling correctly on our line renderer, but the black area is not represented by a transparency, and that's because we need to set the blend mode from alpha to additive in the shader settings. So double click on the shader, go to the graph settings, then change the blending mode from alpha to additive. Save the shader graph, go back to the scene, and now you can see the flames scrolling and rendering correctly. We already finished the first 2 steps, which is creating the texture in Photoshop, then scrolling it using some nodes. Now the third step is to colorizing this texture by creating some nodes that make something like a gradient. We want to lerp the color from one value, one color to another. So let's see how to do that in shader graph. But before we proceed, let's keep things organized and clean by selecting all the nodes we created till now, then right click, group them as one new group, and let's name it main flame texture. To colorize our texture, we will start from the UV node. The UV node represents the surface of our sprite or texture. So this square represents our texture. The left side of it is the left side of the texture. The right side of it is the same. So we want to colorize our texture from left to right, which that means horizontally, of course. To access the horizontal axis, the x-axis, we split the UV to gain access to the x-axis, which represented in the shader graph by RGB. R represent the x-axis, G, green, represent the y-axis, B, blue, represents the z-axis, and alpha is the alpha, of course. So the red channel represents the x-axis. So we will get that axis, then add to it a value of how much we want to blend both colors. So let's create a new float and name it color blend value, then use an add node to add that to the x-axis value. So create an add node, then link both of our color blend value and the x-axis, which is represented by the R channel. And now we can have control over the blend between the 2 colors that we will create now. So if you change the X value of our float, you can see we can control where the blend starts between the 2 colors. Currently, we don't have colors. We have the black and white, but you can see visually the results in the shader graph. Now we will use a lerp node to blend 2 colors using the black and white gradient that we created till now. So right click, create node, and search for the lerp node. So the lerp node consists of 3 parts. The first part is the A value represent the first color in our case. The B value represents the second color, and the T value represent how we blend between those two values. So for the T value, we will use the gradient that we created already, which is the black and white gradient. So link that to the T value. And for the A and B value, we'll create two new properties. First one is color 1, and the second one is color 2. Link color 1 to the A, and link color 2 to the B, and change both colors. You can see how now nicely we can colorize our texture. Or actually, we created an adjustable gradient with two colors. So let's group everything we created till now and name the group flame color. And now to colorize our texture, we simply create a multiply node and multiply the results of the color group with the results of the texture. Now we can see the moving texture colorized from yellow to orange. Then link the results of multiplying to the main color in the master node. Save, go back to the scene, and now you can see our flaming texture scrolling and colored. And of course, if you click on the material, you can change on the fly both colors and of course the scrolling speed. Let me quickly adjust the camera so we can have a better view of our flame. And finally, you can change the background color to a dark gray to have a better view of our flames. And if we hit play, you can see our flames scrolling smoothly. And of course, if you click on the materials properties, you can change both colors and the scrolling speed. In this video, we will make the flames dissolving as they moving to the left. To do so, we will apply the same concept we did for scrolling the texture, but this time with a randomly generated noise. This noise is a built-in node in Unity shader graph, so right-click, create, search for the simple noise node, and you can control the scale of the noise by creating a new parameter, a float, and name it noise scale. Then connect that to the simple noise node, and now you have control on the noise scale. Now we want to scroll this noise the same as we did for the flame texture. So simply create a time node, then create a new property, noise scroll speed, multiply both of them using a multiply node, then link or create a tiling and offset node, and of course to scroll only on the x-axis, create a vector 2, link the results of the multiply to the x and keep the y 0, then link the tiling and offset node to the noise UV. So again, what we're trying to achieve here is to dissolve the flame texture as it goes to the left. So we don't want the noise to appear on the right side. We only want it to appear gradually on the left side. To achieve that, we will be using again the UV node and make a gradient from black to white, which represents where we can see the noise. So create a UV node, which will represent the surface of our noise. Then use the split node to gain access to the x-axis represented by the red channel. And to control where we can see the noise visible, we will create a new property and name it dissolve value, and subtract that from the x-axis value. That will create black and white gradient where it's white on the left, it fades out to black on the right. Then we add that to our noise texture. That will make it dissolve as it goes to the left. And by controlling the dissolve amount value, we can control how much or what is the trends of the dissolve value. And after experimenting a bit, I believe setting the value to 0.33 provide the best results. Now to apply this noise dissolve to our texture, we simply create a multiply node, then multiply the results of the dissolve with our texture. But before we proceed, I like to keep everything organized, so let's group all those noise nodes and name them dissolve. Then create a multiply node and connect both the results of the dissolve and the main texture together. And then multiply that with the color group results. And finally, we need to change from where we're getting the alpha. So we change that from the main texture to be imported from the dissolve results. Save, go back to the scene, and now you can control everything, the noise scale, the noise scroll speed, and the dissolve amount. Keep changing those values till you get a visually appealing flames that is eye-catchy and pleasing for the player. As you can see, each step we add bring our flames to a better visual quality. And now we started to feel or how the flames should be look. The only thing that is left is to remove this sharp edge on the left. So in the next video, I'll show you how to create a mask texture in Photoshop, then how to apply that in shader graph. Now we need to create and render a mask to mask the left side of our flaming texture. To do so, let's create a sample texture 2D, and of course we need a new property, texture 2D, and let's name it mask. We will create the mask in Photoshop in very simple steps. So let's go to Photoshop, create a new Photoshop file with 512 for the width and the height, then fill again the background with black color. Then simply we use the rectangle tool to draw a square with rounded edges. I think setting the edges to be 25 pixels per edge is perfect. Then, after we rasterize the square, we can use a filter, a Gaussian blur, to blur the edges of the square. Export the mask as PNG, then import it to Unity, and let's proceed with the shader graph. So import the mask to Unity, then set the texture to the mask property that we created so we can see it visually. And we just multiply it with the dissolve before multiplying it with the texture, before multiplying it with the color, to remove the sharp edges and get a smooth flames. Now we have everything ready to create the final stunning VFX. So we will need 3 instances of our flame. We will use the first one as the main flame. We will use a second one as a core flame, which is brighter and smaller than the main one. And finally, we will create a third flame to represent the fog or the smoke that emitting from the flames. So let's create a new game object and name it flame, drag the main flame to it, then duplicate it by clicking Ctrl and D on PC. That will create another instance of the main flame, and we need to rename it to core flame, and we need the line renderer in that game object to be half of what the main flame is. So if your main flame is length 2, the core flame should be 1, and also the width should be half. So if the main flame 0.5, the core flame should be 0.25. We should also make the core flame glowy, but to do so we need to enable the HDR property for each color. So let's go back to the shader graph, select both color 1 and color 2, and set the color mode to HDR. We need to change the color of the core flame to a brighter white, but before we doing so, we need to create a second material for the core flame, because if we change the properties of the current material, it will change for both the core and the main flame. To solve this, just create a new material and name it core flame, then drag that material to our core. Now you can change the properties safely without changing the main flame material. So now change the core flame colors to bright white, and as you can see, changing the mode to HDR activate the intensity, which represents the brightness in the URP. But as we increase the intensity, we're still not seeing a glowy colors, and that's because we didn't enable the post-processing in our camera. To enable the post-processing in your scene, create a new game object and name it post-processing, then add to it a volume component. Create a new profile, then override the bloom property and activate it, then activate also the threshold and the intensity and set both of them to 1. And finally, activate post-processing on your camera to start seeing a glowy lights. Now you can adjust the intensity of our core color to control how much glowy is the core flames. And finally, we can create a third instance of our main flame that would represent the smoke of the fire projectile. And again, we can repeat the process by changing the line renderer properties, changing the width and the length, in addition to creating a new material for our smoke and adjusting the properties like the colors of the smoke, the scrolling speed, the noise scale, and the dissolve value. So create a new material for our smoke by duplicating flames 2, assign it to our smoke game object, adjust the properties of the smoke to make the line renderer double of the main flame, choose dark colors for the smoke, and also adjust the scrolling speed to be slower. And here you go, you have created your first VFX using shader graph in a 2D project.